Hello friends, welcome to Learner's Planet. Friends, that is the permutation combination workshop 2, and particularly in this session we are going to discuss the problems on chessboard. Okay, so let's begin this session. First of all, chessboard is there are 64 squares and it's an 8 by 8. Okay, 8 units by 8 units. Okay, 32 of them are black squares and 32 are white squares, right? Alternate black white black white black white. Okay, now I have list of the questions which can be framed on or which are generally framed on chessboard. So let's discuss these basic questions that you can see over here. 32 white squares, 32 black squares, right? Alternate white black white black white black. In a single row or column, there are 4 black and 4 white squares. Okay. Now to be able to solve the questions based on chessboard, we consider the length of this one square is 1. That means this is a 1 by 1 square, and we can say this entire chessboard is of 8 by 8 units. Okay. The very first obvious question is how many rectangles will be there in a chessboard having 8 by 8 squares. Okay. So rectangle is see, when we are counting number of rectangles, even all the squares will be part of that. Okay, so this is a rectangle, this is a rectangle, this is a rectangle. Maybe if you start from this point to this point, and so this will also be a rectangle. If you start from this point, this and this, then also it is a rectangle. So various rectangles are there, so we cannot keep on counting each and every of them, right? So there should be some logic how to find out number of rectangles in a chessboard. Now listen to me carefully. See, a rectangle is framed, just see. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 points, right? And here also 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Okay. Now out of these 9 points, if I select any 2 points from a row, suppose I selected these 2, right? And out of these 9 points, I select any 2, suppose I select this and this, right? Now I selected this from the row and this 2 from a column, like verticals. So if I match, I'll be getting a rectangle. In this case it is a square, but that is also one of the rectangles. So that A, B, C, D, it is one of the rectangle. Similarly, if I select, I just change the color. If I select one from here and one from here, right? 2 points from this horizontal line and 2 points from vertical line. Now further I'll be getting a rectangle. See how? So this is a rectangle, right? So this is how we can get the rectangles. Now there are 9 points horizontally and we need to select 2 out of them. Similarly, there are 9 points vertically. We need to select 2 out of them. So 9C2 into 9C2, that's 9 into 8 by 2 into 9 into 8 by 2. That's 36 square. So that's 1296. These are the total number of rectangles in a chessboard. And how do we get the rectangles? That you must be clear now. Precisely, to make a rectangle, we need 2 horizontal point and 2 vertical point, right? So this is how we can make the rectangles. Now the next question is, what are the different sizes of rectangles? Suppose I ask how many rectangles will be there of 1 into 2, maybe 1 centimeter into 2 centimeter. If I consider this length from this point to this point is 1 centimeter, then how many rectangles will be there of 1 centimeter by 2 centimeter? Okay, so let's try to do that. Now see how do we count that. See, the first rectangle will start from here, right? 1 centimeter by 2 centimeter, right? This is one rectangle that is starting from this point. The second will start from here and end with here, right? The third will start from here and with here. 4, 5, 6, 7. After 7, the last one will be from start with here and end with and over here, right? So 1, 2, 3, 4, 5, 6, 7, right? In the first row, we'll be getting 7 rectangles. Okay. Similarly, 7. So 7, 8 times because there are 8 rows. Similarly, since we are interested in dimensions 1 into 2, we'll be getting the rectangles like this also, right? This is 1. 1 is starting over here, then here 3, 4, 5, 6 and 7, right? The last rectangle will be this. Okay. So per column also will be getting 7 squares. So once again 8 columns are there. So plus 7 into 8. So precisely it is 56 into 2. That's 112 rectangles will be there. I'm sorry, not squares, rectangles. 112 rectangles will be there of size 1 by 2. 1 centimeter by 2 centimeter. Maybe 1 is length, 2 is breadth, and maybe 1 is breadth, 2 is length. Okay. So this is how we can calculate. Similar manner we can calculate 1 by 3. Okay, let's see. Now to get 1 by 3, it will start from here. Then the first will be ending over here, right? So that's 1, 2, 3, 4, 5, 6. The last one will be this. Okay, so per row 6 rectangles will be there of 1 centimeter by 3 centimeter. 1 by 3, right? So each row there are 8 rows, so 6 into 8. These are horizontal. Similarly, as we have seen in the previous case, same number will be in vertical. Okay, so that's into 2. So 6 into 2, 12 into 8, 96 rectangles will be there of dimensions 1 into 3, right? Similarly, if we have to count 1 into 4, so 1 will start from here, 2, 3, 4 and 5 only, because the last rectangle will be this. Okay, so 5 and into 8 each row and into 2 each column. So these are the number of rectangles having dimensions 1 into 4. Similarly, 1 into 5, 1 into 6 can be calculated easily, right? Now the problems can be asked in such a manner, maybe what is the probability that the rectangle has the dimension 1 by 4, right? Out of the total number of rectangles, how many rectangles are there? 196. What is the probability that we select a rectangle and the dimension is 1 by 4, right? So 1 by 4 is 8 5s are 40 into 2, 80. So this is the probability, right? Or in how many ways can we select the rectangles in a chessboard having dimensions 1 by 4? So these are 80 ways, right? So in whatever the ways a question is asked, doesn't matter if you are conceptually clear. Okay. Similarly, now let's try to make the other dimensions also 2 by 3, 3 by 4. The method will remain same, but twist is there. So then let's discuss that. Now suppose we have to find out the number of rectangles having dimensions 2 by 3, right? So the first rectangle will start from here. This is the first rectangle, right? Second, third, fourth, fifth and sixth. At max 6 will, because the last will be 3 by 2, right? So horizontally only 6 rectangles are possible with the length 3, right? Now we see breadth 2. So 1, 2 this way. Okay. Then this is 1, 2, 3, 4 and 5, right? The last rectangle will be like this. Okay. Again count the number of points. 1, 2, 3, 4, 5, 6 and 7, right? So 7 this way and 1, 2, 3, 4, 5, 6. 6 this way. So 7 into 6, 42 rectangles will be there when height is, or this length is 2 and breadth is 3. Similarly, if we take up the reverse, maybe this is 2 and this is 3. This. So in that case, the calculation will be just double. Okay, the same way will be there, but the calculation will be doubled. So precisely what you are doing, you are making the first rectangle with the given dimensions. After that, find out the last rectangle, its initial point, and find out that number. That's it. I repeat it for 3 by maybe 2 by 4 say. Okay, we try to find out the number of rectangles having 2 by 4 dimensions. Okay, now 2 by 4, the first, this. Okay, so just the last one will be this. Okay, because we need this bit to be 2. So 1, 2, 3, 4, 5, 6, 7. 7 this way, and the last one will be, the first one is starting 1, 2, 3, 4, 5, and this is the last. Okay, because we need 4, so 1, 2, 3, 4, right? So 1, 2, 3, 4, 5 rectangles will be there, and the size will be 2 by 4. So 7 into 5. Similarly, we can take up this way, so that will be just double of that. So 7 5s are 35 into 2, 70 rectangles will be there having dimensions 2 by 4. So you find out the initial point, you find out the final point, and count 1, 2, 3, 4, 5, right? Similarly over this side you find out the initial point and find out the final point, and count 1, 2, 3, 4, 5, 6, 7. That's it, nothing else. Okay, now suppose we have to make maybe 3 by 4. Okay, so 3 by 4, we take 3 this way, so that's 3, and 4 this way, so this is 4. Okay, so this way 4, so 1, 2, 3, 4, 5, right? The last rectangle will be this. Okay, start from here and end over here. So this 5, and here it is 1, 2, 3, 4, 5, 6. Okay, the last will be having 3 by 4. Okay, so 1, 2, 3, 4, 5 into 1, 2, 3, 4, 5, 6. 30 rectangles of this 4, I'm sorry, this 3 and this 4, and 30 rectangles when this will be 4 and this will be 3. So that's into 2. So in all, rectangles having dimensions 3 by 4 will be 60. Getting my point? The last rectangle, if I draw over here, is that, this. Okay, so this is 3 by 4, and similarly this is 4 by 3, right? So you can see the first point is this. When we are talking about 4 by 3, the first point is this, second point, second rectangle will start from here, third, fourth, and this is the fifth rectangle. Okay, so this way you can find out the number of rectangles of any dimensions. And the questions, which type of questions are asked, I have already told you. Maybe the probability based questions, maybe a number of ways in which you can select the rectangles of given dimensions, and maybe any other also. Okay. Now I'm sure you must be clear that how to find out the different number of rectangles, the number of rectangles having different dimensions, maybe 2 by 3, 4 by 5, 6 by 7, doesn't matter, right? And now let's try to understand how to find out the different number of squares in a chessboard. Now maybe it is a chessboard 8 by 8, maybe some other figure, some other grid, maybe of dimensions 9 by 8, 8 by 9, whatever, doesn't matter. If you are conceptually clear, you can do the problems based on them also, okay? And how to find out, that I have already told you. How to find out the number of rectangles. See, if it is a instead of chessboard, if it is having a grid maybe of 8 by 9, so you just have to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 9 vertical points, and how many points horizontally, that you have to count. Suppose it is a 9 by 10 grid, then in 9 by 10 grid, so 10 points will be here and 11 points will be here. One more point is there because 2 points make one line, right? So 10 points will be here, 11 points will be here. So 10C2 into 11C2, these are the number of rectangles when a grid of 9 by 10 is there, okay, instead of a chessboard. So this is how you can calculate the number of rectangles. Now, suppose we have to find out the number of squares. Now, as I've told you, this is a 1 centimeter, 1, 1, 1. So precisely this is the chessboard of 8 centimeter by 8 centimeter, right? So you see 8 centimeter by 8 centimeter, a square 7 centimeter by 7, 6 by 6, 5 by 5, 4 by 4, 3 by 3, 2 by 2. So these are the different dimensions of the squares, 8 centimeter by 8 centimeter. Obviously, only one square will be there. So that's 1, right? Now, 1 by 1, obviously 64. So that's actually 1 square, that's actually 8 square. You can see it very well. It will be 7 square, 6 square, 5 square, 4 square, 3 square, 2 square and 1 square, right? So number of squares, if you wish to, like if you can memorize that, that will be easy. 7 by, you just write. Okay, so 2 by 2, that's 4, you write over here, right? 6 by 6, that's 9, that's 16, 25, 36, 49 and 64, right? So this is how you can learn it. Just reverse the series. Okay, 1, this 8 by 8, 7 by 7, 6 by 6, 5 by 5, 4 by 4, 3 by 3, 2 by 2, 1 by 1. You start writing in reverse order. 8 by 8, 7 by 7, 5 by 5, I'm sorry, 6 by 6, 5 by 5, 4 by 4, 3 by 3, 2 by 2, 1 by 1, right? Now how exactly they are getting framed? Just listen to me carefully. Now 8 by 8 and 1 by 1 I don't have to show. 7 by 7. The first square will start from here and over here, right? This is 7 and similarly this, right? So this A, B, C and D, right? Now this A, B, C, D is shifted to this point and this is the, okay? So 2 this way, one step movement this way. Similarly, from initial point, from this point, this is I suppose A dash, B dash, C dash and D dash, right? Now one movement at downwards. So this and this, right? So this is the third one and further like one down and one right. So this is the fourth one. Okay. So this is how we are getting 4 squares of size 7 by 7, right? Similarly, we can find out for 6 by 6. 6 by 6, the first will start from here, then this, then 1, 2, 3, 4, 5, 6 and this, right? So this is the first and here the second will end, here the third will end. I'm sorry, 1, 2, 3, 4, 5. Sorry, this is the first. First will end over here, not this. Second will end over here, third will end over here, right? Similarly, first will end over here, second will over here, third will over here, right? So this is 3 step right side and then 3 step downwards. Okay, so 3 by 3, 9 squares will be there. Similarly, you can calculate for 5 by 5, 4 by 4 and so on. Again, the question can be framed, see how many squares are there having dimensions 4 by 4, how many squares are there having dimensions 6 by 6, maybe 3 by 3, whatever, right? So this is how the questions can be framed, but believe me, it's very easy to answer the questions based on squares on a chessboard. Okay. Now the next question is, in how many ways can we select 2 squares, one black and one white from a chessboard provided that they are not from the same row or column? Now in how many ways can we select one white square? That's 32, right? 32 white squares are there. So that's 32C1. Now from whatever the white square is selected. From the same row or column, we cannot select a black square. I put up an example. Suppose this white is selected, right? Then the black cannot be selected from this line and this line. Okay, that means how many options do we have now for black squares? See, 1, 2, 3, 4. 4 are cancelled vertically, and 1, 2, 3, 4. 4 are cancelled horizontally, right? So in all, out of 32, 8 are cancelled. So what are the remaining number? 24. Okay, so from whatever row or column the white square is selected, from that particular row and column we need to delete the number of number of black squares, right? So that's 32 into 24 ways will be there when one black and one white squares are selected, and they are not having or they are not from the same row or column. Okay. Now the next question with us is, in how many ways can we select two small squares from a chessboard when they have a common side? Now this is other way of asking a question where you have to find out the number of rectangles having dimensions as 1 by 2. So these two squares, right? This two, they have a common side. Similarly, these two, they have a common side, right? So precisely what you have to do, you have to find out the number of rectangles having dimensions 1 by 2, right? So in this row, 1, 2, 3, 4, 5, 6, 7 rectangles will be there, and horizontally if we say this 1, 2, 3, 4, 5, 6, 7, there are 8 rows, so 8 will be there, right? So 7 into 8 of dimensions 2 by 1, and 7 into 8 of dimensions 1 by 2. So in all, 112 squares options you have when you choose two squares and they are having the common side. Okay. Similarly, in how many ways can we select two small squares from a chessboard? They have a common vertex. Now common vertex, if we have to see this. These two have common vertex. These two have, 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 right? So 1, 2, 3, 4, 5, 6, 7 sets. 8, 9, 10, 11, 12, 13, 14. 14 sets between two pair, right? So 14 from here, 14, 14, 14, 14, 14 and 14. So 1, 2, 3, 4, 5, 6, 7. 14 into 7. 98 ways are there. Okay, so pretty simple question. So friends, in this session we have discussed concepts and problems based on chessboard. I hope you are clear with them, and if you come across any problem, if you are not able to crack that, you can definitely send me at alka@learnersplanet.com. And as I told you earlier, the direct questions and the indirect question, and any ways the questions can be asked on chessboard, right? If you are conceptually clear, you can do the problems easily, very well. Okay, bye-bye.